Okay, I think we are about to start.
Yeah.
Yeah. So good evening, everyone. So I would like to welcome you all for today's session. As you all know, 15 15-minute Hikha in this platform. Actually, we have interactive sessions with scientists, mathematicians, historians, economists, and usually they present their talk and it is followed by interaction so that participants can directly talk to the resource person and get to know more about their work and any other relevant information. And today's session, it will be focused on mathematical Olympiads. It's a very, I think it is a lot of students have interests in Olympiads, but sometimes they seem to get confused which Olympiads to go for. Like we have SOF Olympiads, and then we have some Academy of Mathematics. They also organize Olympiads, and then HBCSC. They also organize Olympiads. And today, Ananda Bhaduri is undoubtedly the best person in Assam at the moment to talk about Olympiads. Probably you all know that he won a gold medal in the International Mathematical Olympiad. That we can say is the most prestigious award that you can hope for before college, before joining college. So I'm sure you are eagerly waiting for Ananda's talk as well as the interaction. So without further ado, I invite Ananda to deliver his talk first, and then later on, the interactive session will be there. Ananda.
Yeah. Okay. Thank you. So glad to see lots of people joining, and we can start now, I think. So I've prepared some slides and share them. Give me a minute. Yeah. Yeah. Let's see. So this talk is meant for people from all backgrounds. So some of you may know what this is about. Some of you may have heard of the IMO or something similar conducted by HBCSA. Some of you may be completely new to all of this. Some of you are in college, maybe, and teachers. So could we like disable annotation for this so that it does not become a problem?
Yeah, Ananda, that you can see from your side. I mean, can you go check it at the top of your screen? You can disable it.
Okay, I'll try to do it.
Yeah, please check.
Annotate remote control. Let's see. Disable. Okay.
Okay, great. Thank you so much. Thank you.
Yeah. So so there are people from lots of different backgrounds here. Some of course are high school students who have tried this. So first, okay, what are mathematical Olympiads? So in school, the way they teach you maths is that there are certain types of problems. You are told how to solve those types. You follow this process, and you write it in your exam. You copy. You parrot it. You don't really have to think much on your own. And but what modern mathematics is like, I mean, it's not modern. It has been this way since the time of Euclid. Is that it's all about proofs. So modern mathematics is built on theorems and lemmas, and these theorems and lemmas have to be proved from basic principles. So this style of mathematics is not covered in school, but mathematical Olympiads do give you exposure to this sort of thinking. So high school students typically have very little exposure to proofs. So the only exposure I know is that in maybe class 9 and 10, they teach you some geometry and they prove some things. But even then, what they do is like they ask you to memorize those proofs, and the proof, the same thing you have to, which is proven in the textbook, you just have to copy and paste. It's not really, it's not like you're coming up with your own proofs. So that's not really very useful. And so Olympiads, the thing is that you need to solve a completely new problem, come up with your own proofs, with your own ideas, and that's the whole point of it. So one thing which is very important is problem-solving abilities. And of course, the mathematical concepts which these Olympiads cover are not usually in your high school syllabus. And they start, maybe as a foundation, you require everything covered in the high school syllabus, but they go much beyond that. And so I would also like to clarify that this is very different from SOF, Silver Zone, and those private Olympiads, like those MCQs, and which are all about. This is very this tests something completely different. Like, your problem-solving skills are most important. Sure, there's a time constraint, but it's not like you still have a lot of time to think on your own and come up with your own ideas. So it says my internet connection is unstable here. Am I audible clearly?
Yes, you are audible. You're audible, and you are still on the first slide.
Okay, no, I'm on the first slide. Okay, so
okay, fine. Okay,
yeah.
Maybe if you speak it slowly, because internet is a bit slow. I mean,
okay, right.
Okay.
Okay, so this is the main Olympiad, which leads to participation in the IMO from India. So this is conducted by HBCSE. You can find this link here. You can also maybe look at these slides later. And so this is how it goes. So the first stage is IOQM, which if you are from class 8 to 12, you are eligible to write it. It's a computational exam, meaning that there are no proofs here. I think it's meant as a filter, because since proofs you need to write them in answer scripts, and you need people to check them instead of machines. You cannot take too many people. So IOQM is just meant as a filter, but the problems are still challenging. They go beyond the school syllabus, and they're you have about 3 hours to solve 30 problems. It's usually, you don't need to solve all the problems to go through it, I think. And I would not recommend going for that. I would not recommend practicing so that you get a full 100 or 100. I think something around 20 is a very decent score just to get through to the next stages, which are much more interesting. So from IRMO, the main thing starts. So these are from IRMO, it's all proofs. Like, everything you write needs justification. You need to say that if you solve a problem, you need to say how you arrived at the solution. Even if there's an answer, you need to justify why the answer is correct, and find the answer on your own if required. So it's completely different. And IMO is a 3-hour exam with 6 problems. So it's held regionally. The name is full form is Regional Mathematical Olympiad. So it's held regionally across all the states, and I think per state about 300 people write it. And so again, it's proofs. You come up with your own ideas, and then the top 40 or so students are selected for the national stage. So from each region, about 40 write INMO, which happens in January. Again, this is about six problems and 4 hours. So you can imagine the sort of time it takes to solve one of these problems. It's not like school where if you can't solve it in 5 minutes, you skip to some other problem and move on. This is something different. So it's very much like IMO, but the problems are of course much harder. And then INMO leads to the top 70 or so people are selected to the national camp, and the national camp has the team selection tests, which are the same format as the final stage, which is the IMO. So the team selection tests are the format is something like 3 problems for 4.5 hours. So again, it went from 4 hours, 6 problems to 4.5 hours, 3 problems. So you can imagine that the jump in difficulty, it keeps getting harder from stage to stage. The final stage is IMO. I think IMO is very much the same difficulty as the team selection tests. If anything, I would say that team selection tests like for India or like getting into the Indian team is already a big achievement. And IMO is again it's around the same difficulty as TSTs. So this is how it works in India. The final stage all the way from IOQM to IMO, and this is in fact IOQM happened last Sunday. So some of you may have written it and hope to write some of these next stages. But if not, there's always next year for those maybe who are too young to do it this year. You just got to know about this. So, and I'll discuss things about preparation and so on later. And I'm sorry if this comes off a bit as intimidating, but you still have a lot of time. So, and you learn to enjoy it. So there's nothing to worry about right now. Change slides. Some other things you could look into, which are somewhat similar to the main Olympiads. There's a mathematical Olympiad conducted by AM, which is the Assam Academy of Mathematics in August for students from grades 5 to 11. It's slightly easier than say RMO, but I think it's a good experience if you want to practice. So if you want to know what these things are about. And there are also Olympiads conducted by students of IISc and CMI. These happen online, and there's some forms you need to fill. They have some final round. If you are selected for the final round, you go to IISc or CMI for the final round. These are part of their student fests. So also very similar in difficulty to the main Olympiads. So where does one start? So this is the main thing. The most important prerequisite is that you have some interest in learning new things, and also the motivation to keep going, because it may not be equally interesting to everyone, and that's like completely fine. So if you are interested in this, then you should look into it. And so you need to spend your, so I'll tell you what this involves. So you need to spend your time solving problems. You need to think about them. You need to think about them even when you are not working, like subconsciously, or when you are just walking around. You think about problems all the time. You want to solve them. You are curious about some learning new things. That's what motivates you to pursue this. And there's of course a satisfaction you get from doing challenging things. Right? There's a dopamine boost or something. If you like solve, if you have struggled with a problem for about 2 hours, and then you finally have some hope and you see a solution, that's one of the best feelings you can get. So some other prerequisites is that you need to know the school syllabus till 10th grade, things like geometry. I would say at least the geometry syllabus is essential if you want to, because I think the geometry which you do in Olympiads, it takes off from there. That's the starting point of things, but maybe things like 11th and 12th, which is like calculus or say more trigonometry, it's not really required, but this you should know, that at least the school syllabus till 10th grade, you should be somewhat comfortable with it. What I don't recommend is like maybe going to a textbook and solving the hundreds of exercises there. You should just know the theory. That's enough. Then other 2 books I would recommend, which I think should be accessible. At least the first one should be accessible to people, I think, of all levels. So because the Mathematical Circles, it contains a little bit of everything. It's a Russian book. I don't think it's available online on Amazon or something, but maybe you'll find a PDF somewhere. And so this has a bit of everything. It has some number theory, and it has some problems about puzzles. It has some problems about games. Games as in there are some games where you need to find a winning strategy for each player. It has some geometry. Then it has something to do with counting and combinatorics. So this has a little bit of everything, and I think it should be accessible to almost all of you. And it should be helpful in, at least I think it's a very nice book to develop an interest. And the problems are not easy, so you need to think a bit to solve these problems. They won't come as easily to you, so don't be too frustrated. Just enjoy the book. And if you look at the book, you'll get to see lots of new ideas which you might not have been exposed to. How to solve problems, or what does a proof look like, or how are they coming up with solutions to problems. So things like that, I think it's a very nice introduction. And then there's Challenges and Thrills of Pre-College Mathematics. It is, I haven't mentioned the authors. It's an Indian book. I think it should be available on Amazon. So this, I think, is definitely helpful for beginners, especially I think for IOQM, because it has similar problems. Of course, if you are trying IOQM, then I would also recommend solving lots of problems from past papers and similar contests. So this is something, both of these is something you can look into. Again, there are other things, there are other books which I might have missed. It does not mean that they are not equally good. It just means that I haven't done them, so I cannot speak for them. But you do not have to stick to these two. But if you have to start with something, you might as well start with them, right? And other things, if you just want to develop an interest, is you might have heard of Numberphile and 3 Blue 1 Brown on YouTube. They have some millions of subscribers, and they are very popular. They may have shown up on your YouTube feed if you are interested in this sort of thing. And so I think 3 Blue 1 Brown in particular has some long videos where he discusses a solution with a lot of motivation about where the ideas come from. That might be really engaging. And so 3 Blue 1 Brown is one thing you can check out. I used to watch a lot of Numberphile too. And I think I didn't watch a lot of 3 Blue 1 Brown earlier, but Numberphile was the main thing. And one of these is Raymond Spullion's puzzles books. I used to do these a lot. These are not as popular as the other books I've mentioned. Like Mathematical Circles is a really popular book. These are maybe not so well known. So they have these logic puzzles, like logic is like very basic logic about true and false statements and logical deductions from if this is true, then that must be false, and so on. So this is just pure logic. There's no math involved, but he does discuss some deep mathematics too, like something like Gödel's theorem, which was discovered in the 1930s. So some deep things like those he has discovered, discussed them like in a very approachable way in some of his books. And of course, Jan Stewart is also fairly popular. He has some popular mathematics books for people with all at all levels. Like I think some of his books have some like short articles on mathematics, some recreational puzzles or something, but also some very technical things. Not some of them some of them are at a much higher level, but they should still be fun. And if you want to develop an interest, then you should definitely look at these, or like any other YouTube channel which is similar, which has similar content. So this is just to develop an interest. You may also get some help and advice and some ideas for your Olympiads and problem solving skills too. For those who are already comfortable, like those who have tried, have some experience with proofs, have tried a bit, tried their hand, some maybe they have some experience with these Olympiads. You can try these two books. Okay, I haven't mentioned the book for number theory, but geometry and number theory, I think, are the most technical subjects in the Olympiads, because there is some theory involved. Geometry in particular has a lot of theory, and EGMO is just the starting point. And you gain most of that through solving problems and reading articles or seeing solutions. But Euclidean geometry, he starts at like he does not assume too much knowledge. So what I mentioned earlier, the syllabus till 10th grade. So technically that is enough to like, start this book, but I should mention that it is also very challenging, especially the few problems. The problems at the end of the chapter, which are proper Olympiad problems. So the reason this is challenging is, of course, the reason most Olympiad problems are challenging as well. Even if you know the theory, it's only about like 10% of the deal. Like, most of the deal is like how do you apply the theory? So you know these theorems, but how do you apply them in this particular case? Like, because it may not be obvious at all, like why it is applicable. In school, for example, you more or less know that for this problem I need this theorem or this result. But here, that's the hard part. You need to figure out which results you want to apply, where you want to apply them, and so on. Again, for number theory, one book I would recommend is Elementary Number Theory by David Burton. I think it's quite old. I don't think it was written for keeping Olympiad students in mind, but it's one place where you can learn some basic number theory. Of course, it goes to a level which is maybe out of the scope of Olympiads as well, or topics which are not traditionally covered in Olympiads. So also the book I mentioned earlier, Mathematical Circles, it also has some number theory, which you can look into. But if you want to look into something other than David Burton, that is also fine. So this is for those who are already comfortable. So what do you do next? So you have some understanding of the theory. You maybe you have qualified IOQM, right? And looking for advice about IMO and so on. So as I said earlier, you should expect to spend most of your time solving problems. So maybe I think it's something like 20-80, or like 20% of the time you spend learning theory and 80% of the time spend solving problems. And as I said earlier, the difficult part is knowing like what you have to apply and where you need to apply it. And so in fact, for number theory, in fact, there are very limited theorems you can use. And the tricky part is knowing which theorem is applicable and in what context. So as an example, at the IMO this year, there was a problem which involved Fermat's little theorem, or Euler's torsion theorem. So that's just something you learn very early when you're doing modular arithmetic. So you could say that someone with just that knowledge could understand the solution. But of course, I would assume that everyone at the IMO, or at least the vast majority of them, knew what Fermat's little theorem was. The point was not that they didn't know what Fermat's little theorem was, but they didn't know. First, they didn't know if they had to apply it, if it was applicable, and even if they did, they didn't know how to apply it and how they would use it. So that's why, in fact, this problem had about out of the 600 people who wrote the IMO, I think I got about 200 people solved it, so about 1/3. And I would say even if those 600 knew Fermat's little theorem, the difficulty comes from the fact that these problems are so open-ended that there's lots of approaches you can take, and it is not clear that you have to try one approach after the other and see if this does not work and try something else until you hit upon the right solution. So then that's why I say that your solving problems and gaining intuition is much more important than learning the theory. Right. So this is the website I would recommend for getting all your problems. So artofproblemsolving.com. This links to the contest collection they have. So they have collections at all levels, starting from your IOQM to IMO. Problems from all over the world. They have problems from USA, Turkey, Iran. They have these big collections of problems. And what I used to do is, of course, I used to look through these problems, find a problem I liked, and worked on it. So if you are preparing for IUQM, you might want to look at something. You might first want to look at problems which have appeared in IUQM in the past years, and also problems where problems from similar contests. So you can take a look here and find some problems which at your level. Of course, I think this comes a bit after you're somewhat comfortable with the theory. So this comes a bit later, but this is how you should expect to spend most of your time solving problems. Other useful resources. So there's this online math club which has a YouTube channel and as well as a Discord server. So the YouTube channel, you can find it has some 1 hour, 1.5 hour lectures on different topics, and you should definitely look at them if you enjoy watching lectures or if you prefer studying from lectures instead of textbooks. So the typical lecture is that they discuss a topic, then they discuss some problems related to that topic. So the students who attend the lecture, so the lectures happen live on Zoom every week, I think on weekends. So that's something you can join live too. And they work on some problems and they give the students some time to think about the problems. And that's how it works. And so they also have a website. You can find the website through their YouTube channel. You go to their YouTube channel, they have the link to their website, and then you have to apply to their Discord. There's some form you need to fill. I think they do it to prevent spam. And so their Discord also has lots of people who may be at this, who may be like the similar levels as you. So you'll find someone at the similar level to discuss maths with. That should be helpful. So you should definitely check them out, their YouTube channel, their Discord server, find some people and talk to them about what you're doing, what others are doing. You'll find out a lot. And if you have any questions, I think you should feel free to go to their server and ask it. And you'll usually have people giving you good advice. And some other websites is Rushil. Rushil was a medalist this year. He has been involved in he has been doing this for a long time, these math Olympiads. And his website has a lot of resources, and everything I've mentioned so far should be on his website. So if you don't remember anything from here, you should just memorize rushilmathur.com. You can go there and you'll find everything I mentioned and even more resources. And even he has some FAQs about advice and he has an overview of what math Olympiads are. And so his website has even more, like I didn't recommend too many books for specific topics. He has all those recommendations. So Evan Chen's website, particularly the FAQ and the tips for beginners, is something you should look into. Like he also has a lot of advice about questions like how long should I spend on solving problems? When should I give up? What do I gain from math Olympiads? How do they help me? What should be my philosophy? How should I prepare? How would I, like, more general stuff about preparation? So it has some useful advice. So Rushil's website you should definitely look into and find everything I've mentioned here. And some general advice from you. So do not spend time practicing problems you know how to solve very well. So you do not want to say, you may think like, I want to maybe minimize my silly mistakes. So I'll spend just doing the same problem over and over again. But I don't think it's worth it. Okay, if you want to minimize silly mistakes, that's still understandable, but that's not as productive as learning something new or trying harder problems. So then you actually learn something instead of perfecting something you already know very well. If you cannot solve a problem, you should not just read the solution and move on. I think that is clear that these problems involve a lot of thought and they are not come easy. So you should, this is all very natural, and I think it happens at all levels. Like everyone faces this. If you don't face this, then you're doing the wrong thing. Like if you find them too easy, then maybe you should look at something else. Also, you should also analyze what the solution is all about. So you cannot just like say, yeah, I cannot solve this problem. Okay, here's the solution. I'll read it step by step. So yeah, I read this proof, first step, second step, so on and so on. Okay, I read the whole proof. I understood each step. So that means I understood the proof. It does not actually work that way. So when you read a proof, sure, you can read it like in a like very linear way. You can start at the beginning and read it step by step and make sure that the steps logically follow each other. But even though that's how proofs are written, that's not how proofs are discovered. Like proofs are discovered like this way. Maybe you want to prove X, so you think that, okay, if I prove Y, then X follows. So let me try to prove Y. So if I try to prove Y, then I need Z. If you can't prove Z, maybe you say, I have some conditions given to me, and let's see how far I can go from here. So you do not like go in order the proof is written. You often like switch a lot. You think about what you need to prove. You think about what you have so far, and you try to connect the two. And you should ask yourself how someone would have come up with the proof and what motivated the proof. Like how did this person how did this person think, what order could he have thought of this proof in? Or one other thing is that if I had to describe the proof in a few words, how would I best summarize it so that I would understand it completely? So something like reading it step by step is not always the best idea. And I say that problem solving is frustrating most of the time. You'll spend most of your time stuck. I think maybe you spend 2 hours stuck, and then suddenly in 10 minutes you get an insight and you solve the problem. Or maybe you make a series of insights. For 1 hour you're stuck, then you make some progress, then you're stuck again, then you try to push your progress, so on. And finally, you should try to find people who are interested and discuss these things with them. So this way you'll have a community, you'll have some motivation to learn, you can teach each other, and this is all very nice. So I have some slides left, but I think at this point, maybe I can take some questions as well and then move on.
Okay, so
Yeah.
I have seen some questions on the chat box. So maybe I'll first forward that question by Dipu Kumar, who says, when you are solving a very tough problem whose idea is not immediately clear, what are the things you want to try first? And what is your general thinking process in such situation?
Okay.
You can see it on the chat box, of course.
I can see it on the chat box. Yeah.
Okay.
So one thing which is recommended very often is that you should try and work with examples of the theorem you are trying to prove, and that gives you some intuition of why things are true. So I think it's difficult to describe what why things are true means, but why things are true is slightly different from a proof. So why a theorem is true motivates its proof. So it tells you that, yeah, I need to go along this direction, especially for problems you do not have any idea how to start with. So you can play with some examples and see that. So this is why it's working out. This is why the theorem is working out. So maybe I should try to prove this. And again, maybe try a simpler case of the problem. Try to prove a simpler hypothesis, or maybe add a few conditions. I have to prove X, Y, Z, but can I just prove X for now and see where that leads me? And what if I just try to prove something, not X, but a weaker form of X, something like that? So changing the problem, number one is trying examples and trying to understand what's going on, and that motivates the proofs. Then trying simpler cases, maybe you have to solve a problem for general N. You solve it for N equals 1, 2, 3, and 4. Maybe the proof for N equals 4 does not generalize to the proof for general N, but it is still very helpful. And so you should try things like examples and simple cases to give you motivation.
Okay, so there is a next question by Pradyumna Deka. For solving a problem, what are the important things that we have to look at?
So first of all, you should be clear about what the problem is asking about. And as I said earlier, examples. In Olympiads, you might also want to think like what a solution looks like. Because again, the theory is very limited. So especially as I'm talking about number theory and geometry in particular. So you might want to think like what a solution looks like. So I have these tools. I have, say, Fermat's little theorem. I have some Euler's theorem. I have maybe some other number theory theorems I know, and maybe some very basic divisibility stuff. So how do I use these to solve this problem? Or for things like which are more general, like combinatorics, there's not too much theory, but there are some common ideas, and you can think about, is this idea applicable here or not? And you try things, maybe they don't work, and you test everything you have against the problem, and something will work.
Thank you, Anand. So let me now invite Rifada to introduce our next session's talk. Then we'll again come back to questions. And so Rifada, can you just
sure. I just want to take 1 second to just give you a brief announcement, very briefly, about our next session. So our next session is actually on next Sunday, that is September 22nd, and we will have as guest Dr. Partha Jyoti Das. He is currently a postdoctoral fellow at Harvard University at the United States, and he is going to actually have an interactive session with the students and talk about life in Harvard and how to get there and things like that. So hopefully you will like it, and this is going to be on September 22nd at 7:30 p.m. Hope to see you then. Thank you.
Thank you, Rifada. So now next question was, how much time should we practice mathematics? What do you think?
So as much as you like is what I would tell you. So there's no, so this is all very, I say, this all comes from your interest, and there's some competitiveness and all that involved, some desire for, say, doing well in competitions. But largely, I would say that you should decide that for yourself. And if it is a priority, like in the beginning, I think it may be difficult to devote too much time because you're not very sure about what you want to do, and things are very new and difficult. So then you can just take it at your own pace until you develop some intuition, you develop some theory. Then you can just, if you start enjoying it, I'm sure you'll devote time on your own.
Okay. So there's a question by Ravijit Mahanta. Should we always work on generalized solutions to problems in geometry, or we can find a solution for each case?
So if you're talking about something like IOQM, then what you can do is, since you know that there is an answer, so they give you a triangle and they give you some lengths, and they ask you to find some other length. You can assume information which you have not given, as long as it does not contradict what the problem condition. So maybe the problem statement has a parallelogram, and you assume it is a rectangle, and the problem conditions still hold, and you solve it for the case where it is a rectangle, or maybe things are much simpler, and you get the same answer because it holds true for all parallelograms, so it must hold true for a rectangle. So things like that, yes, you can do an IOQM, and you can solve a specific case and get the answer. But in after that, it does not really work. You need to prove what the problem asks you to prove. If a problem asks you to prove it for a parallelogram, you need to prove it for a parallelogram. You cannot prove it just for a square.
Thank you. So there's a question by Sudipta Kalita. In class, if I am solving a maths problem, should I go with school textbook method, or we should think little bit different, like creative mind?
In class, if I'm sorry, should I go with the school textbook method? No, you should not classify this. This is a school textbook method. This is not a school textbook method. You should try to solve the problem. You should try to think independently of what your school teaches you. So it does not matter if you come at the same solution from some other way. But there's also this thing that there are some hacks taught to you. Maybe you learn them on YouTube or something, and you know these hacks to solve get answers quickly, but you do not really know how they work. Maybe they don't teach you these hacks in school, but if you're learning something like that, you should also know why it works.
Okay. So there's another question. If I want to give Maths Olympiad, then which topic should I focus the most?
Okay, that's also completely up to you. You should focus on what you like the most. So if you like geometry a lot, then you should. I mean, I won't say you should. You can. Like, no one is. Of course, at the end of the day, if you want to do well, you have to learn everything. But um, there's no such preference about geometry, combinatorics. You should just do what suits you the best.
So there's a question by Madhav Avekar.
Yeah.
What should be my philosophy for Olympiad preparation? To win the medal or because I like maths?
Okay, this is a very good question. And okay, I will say that not everyone is completely motivated just because they want to do maths. There's also the yes, I want to go to the IMO. Yes, I want to do well in these Olympiads. Yes, I want to win a medal. So it's a bit of both, right? And um, there's also like I don't think the medal is everything. There's also the medal is just what you do well in an exam, which is about for 2 days, and you get something. But it's really about how you do maths throughout the year and you enjoy it, right? Rather than the medal. But of course, if you don't do well, which happens sometimes, even if you work very hard throughout the year, it's like there is some luck involved. No one denies that. So you may be disappointed, but hopefully you'll still be happy with the maths you have learned.
Okay, so thank you, Ananda. So next question. So it is by Pankaj Agarwal, and maybe I should unmute him because Pankaj Agarwal has been contributing a lot in developing young talents, not only in the country, but he has been doing it in particular in Assam. And probably students may know that he posed 100 problems for IOQM, one each day with solutions. So he has really given a lot of time and effort. So I request Pankaj Agarwal to unmute himself.
Yes, sir.
And maybe you can turn on the video also.
Okay, sir.
Is it
I cannot turn on the video, sir.
Okay, fine. You say it. Okay, you ask your question.
First of all, बहुत बधाई हो. Many congratulations. Actually, as a teacher, मतलब seriously बोलने से मुझे भी बहुत टफ लगता है आईएमओ के क्वेश्चंस. बहुत बार मैं देखता भी नहीं हूँ आईएमओ के क्वेश्चंस. ऑब्वियसली मैंने बहुत पुराने क्वेश्चंस देखे थोड़े बहुत, और क्योंकि मुझे थोड़ा काफी टाइम से पढ़ा रहा हूँ तो थोड़े बहुत पुराने क्वेश्चन तो सॉल्व कर लेता हूँ. तो एक्चुअली दो चीज है मेरे माइंड में कि एक तो मैंने सुना कि तुम्हारा जो ज्योमेट्री है वो तुम्हारा फेवरेट है शायद. एम आई करेक्ट? तो ज्योमेट्री में इंटरेस्ट कहाँ से आया?
Yeah, so I like geometry because that was one of the first things I learned from EGMO, Evan Jen's book. So when I was in 8th grade, I used to do a lot of geometry. So that has stuck since then.
Okay. एक चीज और ना, मतलब जैसे एक्चुअली मैं चाहता हूँ कि मेरे माइंड में कि जब स्टूडेंट्स ओलंपियाड के लिए प्रिपेयर करते हैं तो जैसे बहुत सारे स्टूडेंट्स लोग आइसोलेशन में पढ़ते हैं, मतलब खुद से पढ़ते हैं. मुझे लगता है कि कहीं ना कहीं अगर वो सोशल एक्टिविटी बन जाए, मतलब जैसे you know someone who is equally interested in geometry या मैथ्स ओलंपियाड या समथिंग लाइक दैट, अगर हमारे पास कुछ सर्कल हो तो मेरे ख्याल से वो थोड़ा इम्प्रूव होते हैं. तो मैं चाहता हूँ कि यू गिव योर ओपिनियन ऑन दैट. वेरी एक्चुअली हेल्प्स, क्योंकि मुझे लगता है कि if you say it might be more influential to those who are listening to you. What is your opinion on that?
Yeah, for sure. So I think like having people I could discuss this with, so that helped me a lot, and certainly it kept me very interested. So yeah, I have been part of this, like doing this through Discord, AOPS, or maybe now we are in touch on WhatsApp. So I have been discussing some problems with people I know. Initially I met them online, but I also met them at these camps. So it has been very nice knowing them, and I think that's also a big part of the Olympiad experience, that knowing similar people and knowing similar people who you can discuss these problems with. Yeah, working in isolation is very hard, and maybe some people do it, but it's not something I can imagine.
Okay. Okay. So let's move on to the next question by Tahmid. What should you recommend someone to start geometry from basics and end up at a high level? So starting point for geometry and then for higher level.
Yeah. So first you should be clear with like what they teach in 9th and 10th. They teach you things about triangles, cyclic quadrilaterals, parallelograms, some angles, some theorems about parallel lines, and so on. So those things you should be clear with before. I mean, you can study them from these NCERT textbooks or wherever you want, as long as you know what they are. And then, as I mentioned, it you can try EGMO, or you can try maybe at a simpler level. There's an excursion in mathematics, which is I think meant for RMO. So it has some past RMO and INMO problems which have been discussed. So that is something you can try. And
okay, thank you. And there is next question is by Mr. Manoj Goswami. He's asking that he has a kid at class 4. How can we make him more interested in mathematics subject, not merely a subject to score marks and fear with geometry, calculus, etc. So how
Yes.
to overcome, how to create an interest and overcome fear.
Yes, so 4 is too young, I think. So the one thing I would recommend is like number file and 3 Blue 1 Brown, the things I mentioned on the recreational page, other resources just to develop an interest. So they may be a bit too high level, but Raymond Smulyan's books is something he can try. I think that should be suitable for all ages. There was also this Moscow puzzle book, which I remember. Some very similar things, like you do not need to start studying, say, calculus or geometry from 4th grade, but you can look at these things.
So the next question is related like that. Basan Singh, question by Basan Singh. What is the right age to start preparing for maths Olympiads?
There's no right age as such. But you can start early, even starting late. I know people have done very well by starting late as well. And starting early, you can start, I don't know, 6th, 7th grade. I think you should be comfortable with some, even 6 to 8 is like a good time. You can start. Yeah.
So some people, I think Rushil Mathur started quite late. Is it like that, or?
No, Rushil, as far as I remember, he started quite like 7th or something. He wrote some Olympiad in 7th, and he.
Do you know any of the Olympiad medal winners who started, let's say, in class 9 or 10? Is it?
Yeah. So Rohan, for example, Rohan Goel, he went to the IMO in 2021. And as far as I know, he started quite late, and he did quite well.
Okay. Yeah.
Next
question
there
is
are people like that. Yeah.
Okay, sorry. There's a question by Devasis Kashyap. Does solving Rubik's Cube help us to solve mathematical problems?
Hey, it is something you can pursue as an interest. Maybe I don't know. I don't know how to solve a Rubik's Cube, so I can't comment.
Okay.
It's something I know a lot of people who do maths who solve Rubik's Cubes as well. They know.
Okay.
I think it's very natural to expect that. I myself, I can't solve a Rubik's Cube.
So, okay. So next, one question that by Tonu Nath, what is maths? I suppose he wants to hear your views, how you see maths. How do you see maths as a subject? And I think your internet may have an issue.
For me, it is about, I think it is about understanding. Okay. Is it okay now? I can try to change it.
Now it has come back.
Okay.
Now it has come back.
Great. Okay. So the way I see it is about understanding and discovering new things, proving results from old results, and building things. But I would say the understanding part is most important. What we are really understanding abstract objects. It's okay. That's how I see it.
Okay. So one question by Anisha. What would
Yeah.
you say to a slow learner who loves mathematics?
Yeah, that's a great question. So yeah, you should not call yourself a slow learner, because I'm sure that there are many people who are at your pace, and there's no you can take things at your own pace. Like there's no hurry. You shouldn't feel rushed about taking a like if you're learning something new, you should be very very careful and make sure you understand something. It can take you lots of time, but it's really not worth it if you push yourself to go fast without understanding things.
Okay, so we'll take next question from Shamim Akhtar. Please mention the names Moscow puzzle book and some other name also that you told. So maybe probably you could share the names, or maybe you can put it
the
later
Moscow
in the
puzzle book,
chat.
I'm not very sure. I think it has. I'm not sure of the name. I think I lost the book. It was something like 357 puzzles from Moscow.
Okay, I see. I
So-
see. Okay, so and we have Professor Hirendra Nath from Sam Houston University. He's an economist and he's a core member of our 15-minute Hikka. So I request him to unmute himself and then ask his question directly.
Hey Ananda, it is very nice to listen to your talk. It was really informative and you are very thoughtful in addressing the questions. I have a very simple question. Is there a mathematician who inspires you? And my second question would be, which area of mathematics you are planning to study in the future?
Yeah. So there's a mathematician, Paul Erdős, whom I admire very much. So he's very famous for being eccentric, and he was, of course, very devoted to mathematics. He spent his whole life doing mathematics. He would move from place to place. He didn't have any other interests, and he posed all these problems and solved these problems. He was completely. He had a saying that he would move from one mathematician's place to another mathematician's place all over the world, saying that another roof, another proof. So he would travel around the world and solving problems, no permanent residence. Yeah. And yeah, that sort of dedication is something which I respect very much. I don't think I am quite as dedicated as that, but that is certainly an inspiration. Because which areas I would like to pursue. So Edeshi pursued something a bit more discrete, like combinatorics, number theory. But he had, of course, very important contributions. But I myself, I'm not too sure. I'm still learning, and I could go. I could go into anything which I'm yet to find my interests. Right? But mainly because I know very little. Yeah.
Thank you so much. It's very nice. Thank you. And thank you for
Thank you.
your
Thank
talk.
you. So next question is by Navaswan Bhatta. What hobbies of yours helped in your mathematics journey? And is it okay to abandon all hobbies to focus only on mathematics?
Yeah, so I don't think my hobbies were particularly helpful. So like one thing I used to do is I used to play chess very casually. And the sort of chess I play is very brain dead chess, so certainly did not help me with my mathematics. Should you give up your hobbies? Of course not. I mean, you wouldn't want to give them up anyway. So, as I had mentioned earlier, you should this should come to you naturally. Like, I want to solve this problem. I want to learn something new. You are not forcing yourself. So, if, for example, mathematics is so important to you that your hobbies are immaterial, then sure, you can go that way. But you should it's completely fine if you don't.
Okay, I see. Next question is from Vijay Virange. I have heard that doing several books at the same time is not very productive. Is it true?
Yeah, if you're a bit, so there's this indecision that you need to do this, you need to study XYZ from the best possible book. And so you are confused whether you want to stick to this book or not. I find that it does not matter too much. because at the end of the day, you are doing most of the work, and you are learning things yourself. And there's maybe some book has an different way of thinking about XYZ, but maybe you can also come up with that yourself. So yeah, the book really shouldn't matter. Okay, I would say that some things like some books are easier to read than other books because the authors maybe keep the exposition very concise. They do not give too many details. Then that book is hard. So that is fine. Like if you find it hard to go through a book, then that's fine. But like there's no best book to study.
Okay, I have a supplementary question comes to my mind. Like suppose when you were studying, like is it like you focus on say number theory for 1 month, then you move on to combinatorics, then you move on to geometry, or is it like that you mix do it all together? Which approach do you take?
Just do it all together. Yeah. So after a point when I know the theory about, then I can solve problems so wherever I like. And okay, I think try to be somewhat organized, that I would try similar problems and not try completely unrelated problems in sequence. But otherwise, I don't think it matters too much. You can choose what suits you. Yeah, and I not really have a timetable planned. Like I would have so and so this month.
So that is to speak that basically you follow your interest. So if someone keeps you interested, you just follow it.
Yeah, and also maybe by the time I've planned for next month I want to do something completely different. So it does not matter.
Okay. Yes.
Ananda, sorry to interrupt. I was wondering, did you have some more slides to show before?
I have a couple of slides to show. So are we running out of time?
No, because I thought that we forgot about it.
Okay. Yeah.
We have it on mind. Maybe one interesting question is there. So after that, maybe we can go on to slides like by Ahmed. Please mention your own Olympiad journey. Like what were your scores in Olympiads throughout the years and how you prepared step by step? Of course, partly you have answered, but probably people are curious to know how about your progress, what are your initial scores, and then how you.
So the first time I did it was in 8th grade. Then I used to spend all my time doing geometry because that's what I liked most. And also there was a little that I was afraid of trying something else. So there's a bit of fear, this lack of self-confidence. So I used to work on mainly geometry because that's what I was most comfortable with. And so slowly, of course, I started exploring other things as well. And so in 8th grade, I qualified for this national camp. So INMO that year, there was the cutoff for qualifying was 38. So, and I had the score of 38, so just barely got through. And I was a bit surprised because I did not really expect to go through it knowing so little. So, but again, the camp was cancelled, so I did not get to go there. Maybe that was a good thing because I got to spend all this time at home. The school was online and all that. And then 9th grade, again, the exam did not go too well for me, the National Olympiad. And I did not qualify for the camp, which was again online. So I had a score of 13 on 102. So I had just some progress on one problem. So there are 6 problems worth 17 points each. So I had I think I was quite close to finishing one problem. So I had 13 and I did not make it that year, but again, the next year I made it, I think, I don't remember the score, but I think it was quite comfortable. And next year, the National Olympiad was also the team selection test for the IMO because it all got condensed just because of COVID and some board exams. There were some time constraints. So next year ended up being the selection test for the IMO, which I did not end up going to. I mean, it was something I had hoped for, but it did not happen. And then 11, 12, of course, I made the IMO both times, and both times there was a team selection test. We had a proper IMO training camp, 3-week camp in Mumbai, then in Chennai. So yeah, that was like that was very exciting.
Okay,
Was
Ananda.
that? Yeah.
Sorry. Yeah, no, sorry, continue. Yeah.
Yeah, no, I have answered this question about my experiences. The follow-up question was about, let me see. Yeah, please mention your. How you prepared step by step is, I think I've mentioned the general preparation steps. Also, like, you should not, I would not, I'd not, first of all, I'd not remember what I did step by step, but also it's not something like you should copy. I would recommend it. It might not work for you because it was based on my likes, my interests, and so on. You should, just copying what I did is not the optimal strategy at
Okay,
all.
Ananda, maybe you can go back to your slides, the remaining slides, and maybe
Yeah.
if time permits, we'll come back to questions. So you had some
Okay.
slides.
Right. Let me enter full screen. Yeah. So I was talking about what incentives you have for doing Olympiads. So general problem solving skills, is something not taught at school because you learn some patience. You can think deeply about problems. You can try to come up with innovative solutions. It's something you learn. Mathematical maturity is something like, if it helps you understand like abstract mathematical concepts. Like you can place these concepts in a more, like, you can understand where they're coming from, why they matter, things like that. So this is also something you gain from Olympiads, and it's very useful if you want to pursue mathematics. So these two, the next two are some things I have mentioned. And one thing is that if you are thinking about doing something other than mathematics in college, say it's computer science or physics or engineering, like, it's not really incentivized for you, because right now the only incentives doing well in mathematical Olympiads is that sure you get a certificate or something, but like if you do well in the national stage and you qualify for the final training camp, you get admission into CMI and you have a chance at admission into IIT Bombay's math program. But if you want to study something else, then you'll have to prepare for other exams to get into the college you want, maybe JEE. So that is unfortunate, but it is the way things are as of now. Maybe things can be changed later, and we can have people from more diverse with diverse aspirations pursuing these Olympiads. Because these Olympiads, like, they are helpful in general, whether you're pursuing computer science or physics, they should still be helpful. So I wanted to discuss some examples of problems and show you what some problems look like. But I'll do this only if we have some time.
Yeah, please take your time.
Like if I would prioritize questions about any questions.
Maybe no, I think it is fine, because I'm sure they are staying because they are interested. So
yeah,
kindly go ahead with the slide. Yeah.
So I picked two examples to show you what these problems look like. And so this first is a geometry problem from the National Olympiad this year. It was held in January. So this National Olympiad, as I've mentioned, is the exam for qualification into IMOTC, which is the 3-week-long training camp in Chennai. So okay, so let's read the problem. In triangle ABC with CA equals CB, you have an isosceles triangle CA. I'll show you the diagram. So this is what it looks like. You have CA equals CB. So this is an isosceles triangle. You construct the circumcircle of CAB. So this is something you must have learned in your school, that for every 3 points there is a circle passing through them. And so this is the circumcircle, and so BCE is 90. So E is a point which you construct on this circle such that it satisfies ECB equals 90. So you construct this point, then you construct another point. You construct these 2 points, F and G. So you draw the line through E parallel to CB. You make it intersect AB and CB at G and F, right? And finally, you construct this circumcircle, EGB. EGB, you construct the circle through these 3 points. You consider the center of the circle. You call it O. And what you want to show is that O lies on the circumcircle of EOCF, right? So this is what it asks you to prove. And this is not something you may have been used to, right? Because first of all, it is not at all clear how you would prove such a thing. Maybe you have heard something about cyclic quadrilaterals. How do you prove a quadrilateral is cyclic? How do you prove? So you use known theorems to prove that. And here I have described a bunch of objects which are all like unusual, right? Which you have no idea why they are defined, but somehow at the end, this statement turns out to be true, that this point O, which you have defined in this complicated way, also happens to lie on this circle, right? So how you would go about solving something like this, I won't present the solution, is that you first reduce it to say E, so E, C, O, and F lie on one circle. So what theorems do I know which prove that some 4 points lie on a circle? You try to apply them. Okay, maybe that does not work. Maybe I need to know something more about the point O. Like, what do I know about the point O? O is the center of this circle. So that gives me some information. And then you're going back and forth and trying to discover new things. So one thing you may observe is that O lies on the line CB, right? That was not given to you. It was only given that O is on EGB, the center of the circle EGB. And so if you make a very good diagram and you observe this, and based on your observation, you try to prove this. And so you may not always succeed in directly proving what you want. So there may be some intermediate steps and using other tools which you know of. So any theorem, the information you know about O and E and G, you collect them together to prove that O lies on the line BC. And this is how you make your way to the end. And what a problem like geometry problem, Olympiad geometry problem looks like. The next example I wanted to present was from number theory. So this actually is quite a surprising result for me. This is an old IMO problem from 1987. It was the third problem on day one of the IMO. So the third problems are usually the toughest problems, and they are not really expected to be solved by a lot of people. But times have changed since then. So maybe by today's standards, this problem is not as tough. Right. So what it says is that at n be an integer greater than or equal to 2, and you have this polynomial k square plus k plus n, which is a polynomial in terms of k. You output an integer k and gives you input an integer k and it gives you something. You compute k square plus k plus n, and this whatever number you put between 0 and root of n by 3, then you get a prime number. Then so for this small set of numbers, like relatively small, like sample of inputs, you get the prime number. So for about root of n by 3 numbers, if you input k, you get a prime number. What it tells you is that if you input anything from between 0 and n minus 2, you still get a prime number. So that's like imagine like there's a big difference between root of n by 3 and n minus 2. It's like the square of that thing. So this small information gives you that everything you get must be prime. So this is actually a surprising result. And in fact, this is what's more surprising is that there's actually an example. This is not there's actually an n which satisfies the problem conditions. It's not a vacuously true statement. So for n equals 41, and this was discovered by Euler, that the numbers x squared plus x plus 41 are all prime for if you take between x and from 0 to 40. Anything you input, you get a prime number. And but the thing is, if you wanted to check if it was prime from 0 to 40, the problem tells you if you just check it from 0 to 4 and it gives you prime numbers, then you know that it should also be true from 0 to 40. So that's the surprising part. And hopefully this result has intrigued some of you. How would you prove such a thing? Why is this true at all? And this as well, like, how would you prove such a thing? So this is the end of my talk, and any questions which are remaining?
Yeah, thank you so much, Ananda. So because I see a question coming twice by the same person, and also some other person also asked, although you partially answered it during your talk, but I am again asking the question by Shamim Akhtar. Sir, please mention good books on number theory, combinatorics, functional equations, inequalities, polynomials, and also geometry to start from basics for Maths Olympiad.
So all of this you'll find on Rushal's website. So the one I mentioned earlier. So
Yes.
I am not intentionally mentioning her, and I don't remember their names from the top of my head, but all of this is collected very well on Rushal's website. So you can have a look there.
Okay. And another question, although it came personally to me, but question by Basant Singh, he was asking why there are no girls representing the Indian team, or in general, probably I can rephrase the question that why do boys do better in Maths Olympiads?
So this is of course a very serious problem, and there are some steps being taken to solve it. I think it's primarily a social problem because these Olympiad camps and Olympiad circles, they are frequented by mostly males, and so that may be discouraging for people, like for girls, because they do not want to go into, maybe they do not have people who they can relate with, and they do not have too many people they can relate with, and so they may be hesitant to pursue it. And as I said earlier, that community is a big part of what keeps people interested, and if they do not find such a community, then it does discourage participation.
Okay, thank you, Anand. I think we have taken enough time from Anand. So maybe if there are not many other questions, maybe we are coming close to the end of our session. So Rifat, if you have something to say.
No, first of all, again, so much thanks to Ananda for this amazing talk. And like I saw a very interesting question by one of the participants who said that Nabashwan Bhatta, so who said that would like to see a problem being solved live by you so that we can know how an IMO medalist thinks and makes observations.
So we have lectures like this on Online Math Club, and they have live streams as well. So last week when IOQM happened, last Sunday, there was a live stream on their YouTube channel, and they all solved the IOQM paper together.
Oh, what is I see. Okay, you said what is the channel? What is the channel?
Online Math Club.
Online Math
Club. Okay. So you guys should watch. So Ananda, you said you are there on that session,
No,
right?
I was not there in that session, but I have done, like, I think one previous live stream I was there to solve some paper.
Okay. So there's one question also, maybe like people are so much interested in your thoughts, Ananda. I am reading it. One last question. Is R.D. Sharma and R.S. Agarwal sufficient to build mathematics basic concept? And what type of experience you have got during the time of your preparation for Olympiad?
So R.D. Sharma and R.S. Agarwal, I think they cover mostly the school syllabus, and they maybe go a bit beyond it. But so just as a foundation, I think that is okay. But also NCRT, which is the most basic thing, it's also okay if you just want a foundation. Maybe some harder problems from these books may help you, but you can learn it from NCRT as well. There's no problem. Like just for the foundation, because you'll need to do like other books if you want to go at an advanced level.
Okay, there was another question. Actually, another question. Okay. There was another question I missed, basically, that any tips for those who would write RMO and probably INMO this time? Any tips from you?
So you do not have a lot of time for RMO. You have about maybe 2 months. So if you are starting, what I would recommend is first you learn something properly. So maybe it can be geometry, it can be number theory, something of your choice. You learn it properly. You try to solve some problems on your own, and you look at proofs. You look at like past problems. You look at the ideas there which are involved. So just to get some intuition. So you
So
don't
in
have a lot.
RMO, like how many students are selected from, let's say, Assam? Is it
Uh,
statewise? Is it
Yeah,
statewise
it
or
is statewise. It is statewise. Even
and
INMO, the selection to INMO is statewise. So, um, about I think about 300 students are selected. Like there's a minimum cutoff of 10, which everyone needs to pass, provided they cross that around 300 from each state.
okay, is it like that is for IOQM or
Yeah,
for
yeah. If you have a score of 10 or higher, like on IOQM, then you are eligible to qualify for IMO, and then they select the top 300 in the state.
top 300 from RMO in RMO?
Yeah, top 300 scorers in IOQM, they are selected for to write RMO.
And from RMO, how many are selected for INMO?
About I think 40.
Sorry,
40
40
per state. So
40 per state. And for
yeah,
example, for a state like Assam, what is the cutoff for RMO? It may vary,
I
of
think
course. It may vary, of course. Yeah.
depends a lot on the difficulty of the paper, but it could be 17, which is the score for one problem, or even lower. So 10 or as well, if you have some partial progress on a problem, which is good enough.
Nice. Okay.
Mm.
Okay. Yeah. So Rifata or Hirananda, if you have something to say.
Renata, you have anything?
Nothing. It was an excellent talk. Ananda, thank you for your time, and we are very grateful on behalf of the 15-minute
for having
HICA.
me.
And I know that we know that you are very busy because you will be leaving soon. It's a
Yeah.
new chapter of your life, and we wish you all the best. You sign and you make us proud. You already made us proud, and you make us proud even more. We wish you all the best, and I hope to see you in person at some point.
Yeah.
Thank you. Thank you.
Thank you again. So just to conclude, Hirananda has already mentioned Ananda, and we are really grateful to you for your time and hearty congratulations from all of us. And you can see today that so many students joined the session, close to 100 students joined on Zoom alone. So that means that how much like they look up to you, and then your accomplishment means so much to other kids who are, who want to take mathematics as career, and you're really an inspiration at such age for all of them. So definitely, thanks a lot. And just to conclude, our next session is on September 22nd. That is next Sunday, same time, 7:30 p.m. In India. And our guest will be Partha Jyoti Das. He is a postdoctoral fellow at Harvard University, and he's going to have an interactive session with students. Hope to see you at that time. And thank you all for joining us today. Thank you so much. Ananda, you can stay on for a couple of minutes. So please, thank you.
Yeah, thank you, Anand.